Okay, so I will be waiting for 5 minutes so that some more people can join the session. Then we will be starting the session. So we'll wait for some 2 to 3 minutes more, then we'll start the session for today.
Sure.
Okay, so I'll start the session now. So let me first introduce myself. So my name is Himanshi Singh. I'm currently pursuing PhD from Department of Mathematics, IIT Jodhpur. And I'm your TA for the course Essentials of Data Science with our software 2, Sampling Theory and Linear Regression Analysis. So it is taught by Professor Shalab, and today we will be. So I will be taking this live session, second live session. Okay, so here we will be discussing the content which is being taught by Professor Shalab in week 2. Okay, this is the schedule for the course, the live session schedule. So, which is basically on every Monday from 6 to 8 p.m. These are the important links, which consist of the Google Meet link, which you can access through the Google Drive. This link I have already been given, and this is also present in the announcements in the SWAM portal. And apart from this, the second link is a YouTube link. So in this on this link in this channel, I will be uploading all the recording of this session. Okay, so you can get it from there. And the third one is the Google Drive link. So here in this folder, I will be sharing all the presentations and the R scripts if there are some. So you can access them from this Google Drive link. Okay. Now, so plan for the live sessions will be I will be giving a brief recap about the topics covered in the week 2 lectures. Okay. Now, if there is something which I need to perform in R or show you the demonstration in R, then I will be doing that. Then we will be doing some of the practice examples followed by the doubts. If you have any, you can ask at the end of the session. Okay, so I will be starting this session by giving you a brief recap about the topic. So, for example, I have a sample. I have a population. Population in the sense I have data from which I need to extract some information. So basically, in the field of the data science, we have a data and we want to extract information from that data. Now, about so for example, I want to understand that what is the average height for an Indian. Okay, so for that my population is the total population of India, and uh, but I cannot go to each and every person and collect uh, the heights of the persons or height of the people. So there is also what we can do. We can take a sample and collect that sample and analyze that sample, the data, in order to get some idea about the average height of the population. So basically in statistics we do the same thing. In statistics, in order to study a population, we basically collect a sample and analyze that sample and do some inference about the population. Okay, so we there is also an option to go to each and every person and collect the data from a single person, but that may not be feasible or every time. So we can collect the information by two of the methods. So that is by sample surveys. So which is collection of information on a fraction of total population. So instead of going to each and every person, we are basically collecting information from a fraction of the total population, means some people or a sample from a sample. So this is the method by which we can collect the information or get the information about something. Apart from this, we can do the complete enumeration, means we can go to the whole population. We can consider the whole population and collect the information from each and every person and do the analysis. So these are the two methods. Now, which to choose? So basically, sampling is chosen in many of the cases. Now, why sampling over the complete enumeration? So this basically, because if we do the complete enumeration, if we go to each and every person and ask for some data from that person, then that may be very costly, that may be very time consuming. Okay, so we do the sampling so that we can reduce the cost of the experiment or the survey. And we can also or if there is a less data, then the organization of that data is uh, the data will be more organized as compared to when we consider the whole population. Okay, so that is one of the factor. Apart from that, if I want complete enumeration, I want urgent information about everything. So when we are doing the sampling, we cannot require an urgent information. We so for some person, we believe some of the people, and we consider other of the people. So basically urgent information is not required for the sampling. Apart from that, feasibility, and also the feasibility is basically if some of the methods require destruction of the object. So for example, if I want to know about the average life of a bulb, or average life of an tube light. So if I will go for complete enumeration. For example, a complete company produced 12,000 LED bulbs, and I want to do the complete enumeration in order to see that what is the average life. So it will be time consuming, as well as it will be a it will create a distraction, because there are a lot of all of the LEDs will get destroyed while performing this experiment. So for such kind of experiments, or such kind of data collection, we need sampling. Okay, so now basically what is the idea, that we have in statistics, we have some statistical tools. Okay, so which can give you the statistical inference about the entire population by using some sample. Okay, so basically we'll give the sample to the statistical tool, it will evaluate the things and give us the inference about the population. Okay, so this is the way of how statistics works. But the success of a statistical tool will always be depending upon the outcome. So what is the outcome we are getting, what is the inference we are getting. So whether that inference is correct or not, whether the inference is correct for the population or not, so that totally depends upon how the sample is, what is the quality of the sample. So if we are giving a good sample, then it will give us a good inference about the population. So good sample in the sense that it represents the population. So a sample should be in a way that it should represent the population, so that we can get a good inference about the parameters of the population by considering a sample using a statistical tool. Okay, so this sampling theory is a study which basically provides us a tool for data collection as per the requirement of the statistical tool. So if I have a statistical tool, but that statistical tool require that my data should be collected in such and such way, so that all those things are taken care of by sampling theory. Also, in order to ensure that our sample is a good representative of the population, sampling theory will always help. Okay, so there are different conditions under which a different kind of sampling techniques are present in sampling theory, by using which we can collect a good sample and get a good statistical inference using some statistical tool. So this is basically the idea, that we'll collect the sample, we'll use the statistical tool and get the information. Now that sample should be collected in such a way that it should give us a good inference, uh, more and more precise information about the population. Okay, so there are many type of surveys which are conducted in order to collect sample basically. So they basically collect a sample from a population and analyze that sample in order to get a more information about the population. So there are many surveys like demographic surveys, educational surveys, economic surveys. So basically, if someone wants to know that what is the literacy rate in a particular region, so they'll basically collect some of the opinions of the literacy rate of some of the people. So whether a person is literate or not, they will collect that data and analyze that data and say something about the population, or the literacy rate for a particular area, that how many people are literate, and how what is the percentage of literate people, and what is the percentage of illiterate people. Apart from that, we can also have employment surveys, agriculture surveys. So it always depends upon what is the objective of the survey, and that we will be discussing after some time. So these are the type of the surveys which can be conducted in order to collect a sample to get some information about the population using statistical tool. Okay. Okay, so what are the methods? So we can have a surveys. We have we can collect the sample, but what are the methods to collect that data or collect a sample? So this can be done by physical observations and measurements. So for example, if I want to collect the height, so I can go to each and every person and measure the height for each and every person. Okay, by personal interview. So for example, I will go to the people and I will convince them, okay, just give a personal interview, a personal views on a certain topic, and I will just note those things in a form or something, and I will ask similar things to other persons and I will get a data. And on the basis of that data, I can get some information about the population. Okay, through mails, through transcription from records. So, for example, if there are some records, so for example, how many children are born in a particular region. So I may go to the office where all the birth registrations are registered. From there, I can get some data that how many children are born in last 1 year. I can get the record from there and I can analyze that data in order to get a some information about the population. For now these days we can also get these samples from the online forms or the Google forms, which we basically if I want to know something, I can just make a Google form and just circulate in between the peoples, and they can just fill that form. From there I can get the data and I can analyze that data. Okay. So, these all are the things. Now, apart from this, we have some terminologies that what is sampling unit. So, uh, basically, it is an element or a group of elements on which observations can be taken. So, for example, if I want to know the average height of the people in India, then basically the sampling unit is that an individual. So I'll go to an individual and I will ask the height. So this is the sampling unit, and the collection of all sampling units, it will give me the population. Okay, so the collection of all sampling units in a given region or at a particular time or a particular period, so that will consist of a population. Okay, now the what about the population size? So here in throughout the course we will be denoting the size of the population by capital N and size of a sample by small n. So what is the population size? So if total number of sampling units in the population, so what is the total number of sampling units in the population? That will be the size of the population, and it can be finite or it can be infinite. Here infinite do not mean that it is we are basically meaning by infinite is that n is extremely large, capital N is extremely large, means the size of the population is very very large. Okay, now apart from that we have, so for example, from a population of size capital N, I just took a sample of size small n. Or we can I can say as I took one or more than one, or for example n sampling units from that population, then that collection will be known as the sample. Okay, so it is basically the subset of the population, I can say. Apart from that, we have representative sample. So representative sample mean that all the features of the population is present in the sample. So from the sample only will mean that we are considering a representative of a population. Okay. Now what is sampling frame? So list of all sampling units of the population such that each unit have identification particulars. So for example, uh, I have this sample. Okay, a sample of, for example, balls. Not sample. I have, for example, a population which consists of this six balls. Okay, so these are six balls, for example, and all are same balls. Okay, now if I assign some number, some 1 2 3 4 5 6, some numbers to these balls, then it became a sampling frame, because now we can identify each of the ball by some number. So if we can identify each of the ball by some number, or each of the sampling unit in a population by some quantity, so we have some identification particular for a particular sampling unit, then we'll say that this is the sampling frame. Okay. Okay, so now we'll go towards that. Now we have discussed that we have a population. From there we are getting a sample. We are using a statistical tool and we are inferring about the population. Now, how to get those samples? What are the techniques which we can use to get those samples? Because different scenarios need different techniques. Okay, so in broad sense there are two sampling techniques, that is a random sampling and non-random sampling. So for a random sample we collect the units from a population, and that collection of units is governed by some laws of probability. Means there is no there is a probabilistic approach behind that collection. Okay, so if the collection is such that the rule of the collection of the sample is governed by laws of probability, then we'll say that the sample is random sample. And if the collection of unit is not governed by laws of probability, then it will be a non-random sample. For example, by my thought process only, that these people will be good to get the readings from, to get the data from, and from my early understanding I am just doing some experiment and collecting some data, then that will not be a random sample, that will be a non-random sample, because it includes my personal understanding about something and I'm just using that personal understanding to get the data from. Okay, so that will be a non-random sampling. However, if you have some of the laws of probability running behind collection of the sample, collection of the units from the population, then that will be a random sample. Okay, now uh, this variability control in a sample survey. So for example, if the sample we are collecting have a lot of variability, for example, if I'm collecting so for example, if I'm collecting uh, three types of things. For example, I'm collecting a ball which is this small, a ball which is this small, a ball which is this small. So these three kinds of balls are present in a population. So these three kinds of ball I'm getting, and there are many balls which consist of this ball, this ball of this size, ball of this size, ball of this size. So we have three kinds of balls there. Okay, but the variation of size is very like this ball is very small compared to this is very small compared to this. Due to this, the variability of the sample will increase. Okay, so we have to control that variability also. So for that, in order to control these things, there are many techniques. So if I'm having this kind of scenario, then there are many techniques by which we can just divide the population into certain parts and then select the samples from those parts. Okay, so before the selection of the sampling unit, there is stratified sampling. Okay, cluster sampling, two-stage sampling. So basically here in cluster sampling, we make clusters. Okay, so from population we make, so if this is a population, then we make clusters of similar kind of things. For example, I made three clusters. Now I will be collecting sample from here, and from here, and I'm getting a sample here. Okay, so this is done in order to control the variability. So if there is a variability in the population, then these kind of techniques are used. And at the time of the selection of sampling units, this is systematic sampling, varying probability sampling, and there are many more. So we will be discussing those in the forthcoming lectures. Okay. So these are the, this variability control is very important sometimes whenever there is more variability in the population. Okay. Okay. Apart from this, now how to conduct survey? Okay. So if I want to conduct a survey, so first of all, we need to define the objective of the survey. So what is the objective of a survey? We have to define that. Okay. So for that, so for example, let me give an example. So I want to estimate average height of an individual in in a city, for example. I am here only considering a particular city. So what will be the objective for that? So what will be the objective for that? So that will be the uh, to estimate average height in a city. Okay. Now, what is the population which need to be sampled? First of all, I need to know that what will be the population which needs to be sampled. So what will be the population? So people of the city, all the people of the city. So that will be the population. Okay. Now decide the data to be collected. So what the data will be collected? Height of an individual. So height of individuals. Okay. Now decide the degree of precision and method of measurement. So what is the method of measure? So whether I am measuring the height in inches, okay, in centimeters, in millimeters, whatever. So that is the method of measurement I should decide. Okay. What is the sampling frame? Now what can be the sampling frame for that? So for a individual, uh, I can have list of I can have a list of birth certificates, I can say. So I'm here assuming that all of the person are having birth certificate, and I can have a list of birth certificates, and each of the individual have birth certificate. I can assign that number to each of the individual. Okay. Okay, now scheme of selection of sample. Now that scheme, so what should be the scheme? Now how we are selecting the sample? So whether we are using simple random sampling or stratified random sampling or systematic. So which sampling technique I should follow in order to select that sample? So that is also important. So these things we will be studying further, that what are the sampling techniques which are used to collect a sample. Okay. Then we need to conduct a pre-test. Okay. Now conducting a pre-test will give us a idea that how the things are working. People are finding some difficulty in order to give the information or something like that. Then through that we can maintain the organization of the fieldwork, that what is basically happening at the field. Okay, then we'll just do that all the collection of the sample we can do at the field. And then we'll also decide that how to present the summary of the data and how to analyze the data in order to get the average height. So here we will be needing, in analysis of the data, we will be needing the statistical tool. Some statistical tool is needed so that we can analyze the data in a right way, so that we can get the average height of the individual. Okay. And also at the final stage, how to use the information gained for future surveys. Okay, so how can we use the information for future surveys? Fine. So these are the key points which we should know while we are conducting a survey. We should follow while we are conducting a survey. Okay. So if anyone have some doubt, then please ask. Then we will move forward towards the questions. can also say births. Okay, so if there are no doubts, then I will be moving forward towards the questions. Okay. So here the question one is, a state government wants to estimate the average monthly expenditure on food of households in urban areas of Rajasthan. So basically now here we are considering that the government wants to estimate the average monthly expenditure on food of households in urban areas of Rajasthan. So so basically urban areas of Rajasthan is considered, and we want to know that what is the monthly food expenditures of the households in these areas. Okay. Now due to time and budget constraints, only some households are surveys. Now it is obvious that we cannot do the survey for each and every house present in the urban areas of Rajasthan, because there are a lot more houses are there are many people, so this is not cost and time effective in order to do the survey on each and every sampling unit. Okay, so here first of all we need to identify that what is the objective of the survey. So what is the objective of the survey? Okay, what is the objective? So to estimate the average monthly average monthly, or I can say yeah, monthly food food expenditure of household in urban areas of Rajasthan. Okay. Now, what is the population under study? So, what is the population basically? So, population is households, all households in urban areas of Rajasthan. Okay. Now, what is the sampling unit in it? So, what is the sampling unit? A household. Okay. What could be the suitable sampling frame for it? Okay. So, it can be sampling frame can be list of electricity connection numbers, I can say. So the electricity connection number is unique for each and every household. So the list of electricity connection number can be the suitable sampling frame. Okay, and it will be unique for each household. We can also take another any other list to be chosen as the sampling frame. There is no issue. Okay, is this a census or a sample survey? So since we are basically considering only some households which are surveyed, so it is a sample survey. Okay, so it is a sample survey. So any doubt in this? So for this problem, what we have done, basically the objective, first of all, we found out the objective. What is the objective? So we want to know that what is the average monthly food expenditure of a household. Now, here we have first of all found out the objective. Then what is the population we are considering? So what is the population? We are considering the all the households in urban areas of Rajasthan. Then what is the sampling unit? A household will go to a particular household. Now what we will ask for? Okay, so we'll ask for or we'll get the data, that is that what is the average, what is your monthly expenditure basically. So we will be asking for monthly expenditure. So we will get some 1500 rupees, 1700 rupees, or whatever, 12,000 rupees, whatever. So we are getting that basically a quantitative, or I can say a numeric data. Okay, so I'll get numbers from each household. I'll get some numbers, and those numbers I will treat as my sample. And okay, I will be then analyzing that sample in order to get that what is basically the average monthly expenditure of food in the households in urban areas of Rajasthan. Okay, so I will go to the particular household in urban areas of Rajasthan. Now, how I will be choosing those households? So that is basically the concept of sampling theory. So that we will not be discussing now. That we will be discussing maybe in the next lectures. Here we are only concerned about that how to know the objective of a survey, how to know the populations and what is the population, what is the sampling unit, what is the sampling frame we can consider, and what is the data we are collecting. Now is that data is a, or is that whole process is a sample survey, or is it a complete enumeration? Basically we are considering those things. Okay, so if there are some doubts or something like that in this question, or in this uh, concept. Okay, so we'll move for the next question then. Okay, so a university administration wants to know the percentage of students who are satisfied with online classes. Okay, so they basically want to know that whether the students, how much students, or what percentage of students are there which are satisfied with the online classes. Okay, so the university has 12,000 enrolled students, but the data is collected from only 600 students. Okay, now, first of all, we need to state the objective of the survey. So basically, what is the objective of the survey? Okay. So what is the objective? To estimate percentage of students satisfied with online classes. Okay, so this is our objective. Now, what is the population under study? So what is the population? So all enrolled students in the university. Fine. Now, what will be the sampling unit? Now, so this population consists of all the students. Okay. So it will be, so here it will be 12,000 enrolled students. Now, what is the sampling units? The sampling unit will be an individual student. Fine. Now, what could be the sampling frame? Now, what can be the sampling frame? We can have a list of or I can say list of, yeah, enrollment numbers of students. So basically the enrollment numbers for all these students will be different. So it will be unique, and it will be a number. So basically a unique identification is assigned. Now each student, now two students may have same name, same surname, but the enrollment number will be different for each student. So a list of enrollment numbers will be the sampling frame. Now what type of data will be connected? Now basically we want to know that the students are satisfied or unsatisfied. So we'll collect the data as basically a categorical data. Categorical data is basically the data will be in category that whether the student is satisfied or not satisfied. So basically we'll collect the data like whether a student is so we'll ask the student whether you are satisfied or not satisfied, that he or she will give us the answer in whether he or she is satisfied or not satisfied. So here the data is not numerical, we are getting a categorical data, and we'll apply some of the statistical methods or statistical tool on this type of data, and we'll get some inference about the population. Okay. So any doubt in this question? No? Okay. So we'll move forward for the next one. Okay. So a health department conducts a survey to estimate the proportion of children below 5 years who are fully immunized in a district. So basically, health department conducts a survey to estimate that how many students, oh sorry, how many children below 5 years are there which are fully immunized, means they got all the vaccines. Okay, so the main objective is to estimate proportion of proportion of children, okay, below 5 years who are fully immunized. Fine. In a district, obviously. Now, what is the population under study? So, what will be the population? All chil children below 5 years in a district. So, the population will be the all the children which are there, which are below 5 years in a district, which are residing in that particular district, and which are less than 5 years. So, all children will be the our population. Fine. So now what will be the sampling unit? An individual child. So, but a child now, an individual child. So there are there the child. So if there are many children, all the children which are below 5 year, an individual child which is below 5 year. Okay, so that will be our sampling unit, and that will constitute all the individual child which are below 5 years in a district. That will constitute the population. Now, what could be the sampling frame? We can have their birth registration. So birth registration number. Okay. So list of birth registration number. Now here we are assuming that all the children below 5 years, uh, they all have the birth register. Their birth is registered. Okay. Now if I'm considering this sampling frame, and but there are some children which are whose birth are not registered, then there may be a bias, or there may be a some of the like we are missing some of the children which are below 5 year, and then the inference about the population may not be that accurate. Okay. Now what type of data is being collected? Now here I want to know that whether the children, whether the children below 5 years are immunized or not. So we'll go to each child. or the parent to the parents, and we'll ask that whether the child is immunized or not, and they will give us the answer in yes or no. So answer will be yes or no, so that the answer will be, so we'll get a categorical data. Basically, we're collecting a categorical data. Okay, so here the data is not numerical, we are collecting a categorical data. So whether the child is immunized or not immunized, we'll get the answer in yes or no, fully immunized or not. So can you please keep your microphone off, because there is some sound. Okay, so is there any doubt in this question? No? Then I'll move forward for the next one. Okay, so here the question is that a company manufacturing electric scooters want to estimate the average distance traveled per day by scooter owners in a city. So a company manufacturing so the company is manufacturing the electric scooters, but it wants to know, or it wants to estimate that how much distance is traveled by a person or the scooter owner per day. Okay, a list of registered scooter owner is obtained from the RTO. Fine. So now here, first of all, we want to know that what is the objective of the survey. So what we want to know, so we want to know, or we want to estimate average distance traveled per day. Okay, by scooter owner, I can say by scooter owner, and we are talking about in a particular city. So in a city. Fine. So we want to estimate that what is the average distance they are traveling, the scooter owners are traveling per day. Now, what is the population under study here? So what can be the population? What is the population for this study, for this in order to collect the sample? What population we want? So we want so here all scooter owners in the city. So all the scooter owners will be the population for this survey. Now, what will be the sampling unit for it? So it will be an individual scooter owner. So an individual scooter owner will be the sampling unit. Fine. Now, what could be the suitable sampling frame? So there can be the suitable sampling frame can be, so that as mentioned in the question only, a list of registered scooter owner is obtained from RTO. So we can get a list of registered scooter owners, okay, in the city. We can get that list, and that list can be it will act as a sampling frame. Now, what can be a possible source of bias in this survey? So is there any bias or anything which behave like a bias in this survey, or something which we are missing by considering any particular assumption here? So basically here we are considering the sampling frame to be a list of registered scooter owners in the city. But what if a particular scooter, or there are many some scooters are there which are not even registered? So that will create a bias. So there may be a possibility that the scooter owner is not registered, and we are basically we are not analyzing them, we are not collecting data about those scooter owners, and they may be having a high rate of traveling, or they may have very low rate of traveling. So if there are very many scooter owners which are not registered, then that will affect the inference about the population, whether that the average distance of traveling per day by a scooter owner is like, it may affect it, that whether it is a low or it is high. So it basically affects that if the scooter owners are not registered but they are traveling more. There are, for example, out of total 100 scooter owners, 20 are not registered, but they are traveling very, like, the rate of travel is very much very high. So if we are not considering those 20 scooter owners and we are only doing taking the sample from the other 80 scooter owners, then it will basically affect on the inference about the population. So basically here what we can say, that all scooter owners may not be registered. So that may create a bias. Okay. So that may create a bias. Fine. So any doubt in this? No? Okay, then I'll move for the next question. Okay. So here, an agricultural researcher wants to estimate the average yield of wheat per hectare in a particular state. So basically, the researcher want to estimate that what is the average yield of wheat per hectare in a particular state. Basically, so what is the objective here? As it is clear, to estimate average yield of wheat. Fine. In a particular state we are talking about. So what is the population under study? So what will be the population? So uh, agricultural land which is basically producing wheat, that will be our population. Okay, so all agricultural fields with wheat production. Yeah, and obviously it is in in that particular state. In that particular state. Okay, fine. Now what is the sampling unit? So what will be the sampling unit? Yeah, one wheat field. Any field with wheat production, I can say. What data should be collected? So what we should collect from that particular? So we'll go to a particular uh, field. A sampling unit is a field, so we'll go to the owner of that field and we'll ask for what. So because we want to estimate the average yield, so we will we'll ask for the average yield. Average yield, yeah, per hectare. Or we'll just ask that what is the total yield, what is the total area, and we'll just calculate that what is the yield per hectare, not the average yield, basically yield per hectare. Average yield we need to calculate, so it will be yield per hectare. Of course, the wheat yield. So that field is wheat production field, so it will be all yielding wheat only. So it will be yield per hectare. Fine. So now is for this the population is finite or infinite? So here we are considering the population to be the all agricultural field in wheat production in a particular state. So of course that population is finite. Fine. So yeah, so this is basically about this question. I hope this is clear. Now, in this case, if someone asks that what can be the sampling frame for this thing, so we can so the land is basically is at the name of some person, and it may have some registration number or some particular number. So that list of that registered lands on registered land can be acting as a sampling frame. Okay, so that will give a unique identification to each of the field, and we'll get the sampling frame. Okay, now this is another question. So here, so a market research firm wants to study consumer preference for different brands of cooking oil in India. So basically, for example, let us consider that there are five cooking brands: B1, B2, B3, B4, B5. Yeah, in sampling frame, I think it should be only the wheat yielding field, because basically we are concerned with the wheat fields only. Our population also includes only the wheat fields. So sampling frame should be the list of the wheat fields only. Yeah. So basically, what sampling frame does, it basically gives the unique identification number to each of the sampling unit present in the population. But here, in our population, we are considering the wheat fields only. So yeah, it will be the wheat fields. So a market research firm wants to study consumer preference for different brands of cooking oils in India. So for let us consider that we are considering only the five brands of cooking oil: B1, B2, B3, B4, B5, and our objective. So what a market research wants to study, that what is the preference of the consumers for different brands of cooking oil. So first of all, the objective will be the consumer preference. Consumer To know the consumer preference for cooking oil brand. Fine. Now, what is the target population? So, target population can be, so there can be two things. Whether we can whether we can consider the population to be the all the households, or we can consider as that we are going, or we are considering to like it is a consumer thing or a household thing. So it can be an household, all households in India, or we can say a consumer in India. So according to that only we will decide other things. Okay. So basically we consider all the households in a broad sense, because each household, the whole household, if they are four persons and all of the four-person are consuming the same cooking oil, and they may have the same preference of the cooking oil brand. Now, what is the sampling unit for it? Particular household. So an individual household. Okay. Again, as we discussed in the previous one of the question, we were talking about. Yeah. That is the same thing. Target population means that which population we want to consider as a our whole population, from which we will be collecting the samples. So that is the same thing. So the sampling unit is fine. Now, what will be the sampling frame? So as we discussed in a previous question, that sampling frame may be the a list of the electricity connection of households. So we can have, so the electricity connection of each household will be unique, and we will have a list of all the electricity collection of the households, and it will give a unique identification to each of the household. Okay, so if we are talking about the sampling frame, now here what type of data is collected? Now, if I want to know that what is your preference in brands, then what type of data can be collected? So it can be like the data, obviously it will be a kind of a ordinal data, we can say. It is a kind of a categorical data, so which basically gives the order to the brands. For example, a particular person, here I can say categorical data will be there. Okay, now how can categorical data be like, we can have an option that we will give brand B1, B2, B3, B4, B5, and we'll ask to rate these brands. Okay, so or we can say that this is the first preference, this is the third preference, this is second, this is fourth, and this is fifth preference. In this way, we can ask that that brand B1 we are getting 1, B2 3, B3 2, B4 4, B5 5. In this way, we can get the data, or we can say that B1 is excellent, B2 is good, B3 is very good, B4 is we can say average, and B5 is below average. Okay, so in that way we can collect the data. So here one of the ways, like we are getting like number 1 2 3 4 5, so it is basically increasing when the quality of the or the preference of the it is decreasing, then the numbers are increasing. Or we can get like B1 B2 B3 B4 B5, so it depends upon the research firm that what the way they want to decide. So it is, for example, for B1, they are giving that it is excellent, it is good, it is very good, okay, and it is average, and it is below average. Okay, so this kind of data. So from a particular household, we get this kind of data. Okay, this kind of data. So obviously, this is not a numerical data. It is a kind of categorical data, and where we are giving orders to particular. We are ordering the quantities under consideration, or the brands under consideration. So this is basically a study in statistics. There is a particular study in statistics where we are analyzing the categorical data, and there are different methods to analyze those data in order to get inference about the population. Okay, fine. So is there any doubt? Okay, so we'll move for the next question. So here these questions are like, we want to indicate that whether a sample survey is good for a particular experiment or a particular inference about a population, or a complete enumeration is necessary or is useful. So what is basically useful in a particular scenario, and why? We have to give the reason also for these questions. Okay, so you need to tell me that whether a sample survey is good or a complete enumeration is good, or we can do both, or if we are doing whatever we are choosing, then why we are choosing it. Fine. So here in the first question, it is given that a company wants to estimate the average lifetime of 1200 LED bulbs produced in a new manufacturing process. So in a new manufacturing process, 1200 LED bulbs are produced already. Now, if a company wants to know that what is the average lifetime. So what do you think that a sample survey is good for it, or a complete enumeration is good for it? Yeah, so for this, we will do a sample survey, because the complete enumeration is first of all, it is very destructive. Okay, and it is time consuming also. Fine. So because of it, we will do the sample survey. Fine. Now for the next question, we have a school with 60 teachers wants to decide the timing of weekly staff meetings based on teachers' preference. Okay, so school have only 60 teachers, and they want to decide the timing of weekly staff meetings based on teachers' preference. Okay, so what should be the way to do that? Yeah, so we should do the complete enumeration. We can do, because the sample, or we can say the population is small. So it will not be that much time consuming. It will not be that cost, that much of cost. It will also not be the case, because there are only 60 teachers. It is feasible also. We can just reach out to the teachers and we can ask for the timing that weekly, for these weekly staff meetings. Fine. Again, next question. A pharmaceutical company wants to test the potency of tablets produced in a batch of 5,000 tablets. So 5,000 tablets are the produced. Now we want to know. So the reason may be acceptance by each means. No, 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 no. We cannot say that acceptance. The reason is not about the acceptance. So, for example, in place of 60 teachers, if there are, for example, 5,000 teachers, okay. So we cannot say that we will go to every teacher, and we'll ask for the weekly staff meetings. We cannot do that, because that will be the population is very large. So here, for this case, because the population is small, so the everything is it is not that time consuming to do the complete enumeration. But if there are 5,000 teachers, so what we can do, we can select the teachers from every department, some of the teachers from every department. Okay, so that we can have the availability from those teachers at a particular department. Or we can have, for example, we have 15 to 16 departments in a particular university, or maybe more than that. Then for the each of the department, we can get some of the teachers, and we can ask them about the timings, and we can just do the further process with their preference. So you are telling what quota sampling? Quota sampling is a different thing. The quota sampling, we basically do that a prefixed number is first of all decided. So, for example, whenever if I want to have if I want to have an information about for example, a rare disease, I can say. Now that rare disease may not be available. So if I go to a particular person, that person may not have that disease. So it will not be giving me that kind of response. So here I will decide that, okay, I want 20 samples. So I'll go to each of the person, ask for that whether there are whether the particular I'll ask that whether the particular disease that person has or not. And unless I get the 20 readings, I will at the time I get the 20 readings, then I will be like happy that, okay, fine, I have the 20 samples, now I can further analyze these samples. But how that is connected with this? Here basically I'm saying about the complete enumeration, whether we can do the complete enumeration or we should do a sample survey. So how that is connected to this quota sampling? Yeah, if you are assuming 5,000 teachers, yeah, in those things, if you are saying that, okay, I want then if you are prefixing the things, if you are prefixing, okay, so 100 I fix it, 100 teachers I fix, and I will go to each teacher, and until unless I get the 100 yes, then I will be like taking the times. Or in what way you are asking? For 5,000 teachers, I am saying that whether it is possible to do the complete enumeration. That means that whether it is possible to go to each and every teacher and ask that whether they are okay with that timing, or what timing do they, if I decided a timing, to whether he or she is okay with the timing, yes or no, yes or no, from whether it is possible, or I should select a sample and then do the things. So here I'm talking about a survey, whether I should conduct a survey, sample survey, or a complete enumeration. But the quota sampling, you are already talking about the survey, the sample survey. Here the question is whether the complete enumeration is needed, or I can do the thing with the sampling also, or the complete enumeration is feasible or not. Basically, the question is that. But if you are talking about the quota sampling, so there we are already talking about the sampling only, no? Yeah, sampling. So no, the sampling unit maybe, yeah. So here there also come two different things. That we are at the primary thing, we are taking the departments, and then at the secondary, so that will be the primary sampling unit. Then the secondary sampling unit will be the teachers only. So actually there comes the concept of those two different things. So because at the end of the day, we want teachers only to respond. The department at its level cannot respond. So first of all, the primary sampling unit will be the department, and secondary sampling unit will be the teachers only. So there comes a different. So that is basically when you learn about the stratified sampling, or the cluster sampling, in those things, these things will come into picture. So those things we have not studied yet. So we'll study in forthcoming lectures about those sampling techniques. Okay, is that fine? Is that fine, or any doubt? See, that depends upon the study. If I'm saying, okay, fine. If I'm saying 5,000 teachers are there, okay. So is it possible, like intuitionally, is it possible, or it is always no, so it the so it always depends. So for example, if there are 5,000 teachers and 60 teachers, so complete enumeration for 5,000 teachers may not be that cost effective. It is not necessary that that you should do a sampling. So it depends upon you only. But due to the cost effectiveness and time consuming thing, so a person cannot go to each and every to the 5,000 teachers and ask for that. No, so that is basically not that practical. But if there are 60 teachers, I can go to each and every teacher and ask for that. So for example, if I want to know something about a particular class, then I will ask to each of the student that okay, just tell me this information. Then it is fine. But if I want to know about the whole school, then it is not that possible to go to each and every student or the faculty of the school to ask something. Then I will collect a sample and do the things. Is it fine now? Okay. So now in the next question, a pharmaceutical company wants to test the potency of tablets produced in a batch of 5,000 tablets here. Okay, so we want to know that potency of the tablets, whether the tablet is effective or not. Okay, then so what should we do? A complete enumeration should we do, a sample survey? Because here we are, the tablets are produced and 5,000 tablets are already produced. Now we want to know that what is the potency. So should we go for the complete enumeration? Yeah, so we'll go for sample survey, because if I destroy all the 5,000 tablets, then that will be destructive. Okay, due to um so the production of that tablet will be most probably will be like it will be having a high cost. But if I destroy 5,000 tablets, that will be a destructive complete enumeration. So I will go for the sample survey. We'll take some of the tablets from it and analyze their potency on the basis of whatever requirements of that tablet is, and whatever the mm, advantages of that tablet. So how to judge, that is also all, that is all the things are depend upon them. Here we are only considering that we will consider a sample or a complete enumeration. Okay, fine. Okay, so a hostel having 150 students wants to know students opinion about the quality of food in the mess. So here we have only 150 students, so we can go for a complete enumeration, because what we can do, we'll just float a Google form and mail to 150 students, and we'll just ask them to fill that form, that whether the quality of food according to them, what is the quality of food, whether it is good, excellent, very good, or average. And we'll just get the data from there. And because there are 150 students, it is not that um, tough to analyze that data in order to get information that whether the students are happy with the mass food or not. So for this, we'll go for the complete enumeration. Okay, reason, because the population is small, I can say. Fine. Now again, a government wants to estimate the unemployment rate in a state. Now, what should we do for this? Unemployment rate in a state. So do we go for the sample survey or to the complete enumeration? For the census, you would. So actually, I don't think so. Census, because in India, otherwise also census is conducted after 10 years. So each year, every time it is not possible to conduct a census, or it is not that cost effective. So for the unemployment rate, a sample should be collected in a state, because in a state there are many people. So going to each and every person is not that feasible. So it is not that cost effective. Also, it is not that. So what do you mean by that? Through employment exchange. What do you mean by that? I'm not. I'm not getting what you are trying to say. So basically, if I want to know the unemployment rate in a state, then I need to what data I should collect. That I should go to each person and ask that whether that person is employed or not employed. Okay, in order to in or from some records I can take, but there are many people in a state. There are many people in a state. How to know about each and every person? So basically, what we can do, we can just go to a particular districts or particular villages and ask, take some sample from those villages, and take some samples from the cities, take some samples from the towns, and we may analyze those things with a less number of people, with a less number of data, in order to get an employment rate in a state. So we will consider each and every uh, um, uh, city, not city, each and every kind of. So, for example, if I'm in a village, then there may be a possibility that there are more number of people which are unemployed as compared to the people present in a city. Okay, so we should consider each and all those aspects and collect a sample from the places and get the information about the whole population, because to going to each and every person is a it is not that cost effective also, and it is very much time consuming. Okay, so we'll go for the sample survey for this. So these things are like completely subjective. There is no particular answer is correct or particular answer is wrong. So these are a little uh, subjective things. It totally depends upon how the statistician or a researcher is thinking about the situation or about the survey. Okay. So here we can say that the complete enumeration is time taking and costly. Okay, is there any doubt in this? So should I, so shall I move forward towards the next question? Okay. So here in this question, we want to indicate the whether the following sampling techniques are random or non-random. So basically, random, which I've discussed already, that whether it has some of the background that the sample we are collecting have some of the uh, intuitive probability, which is basically coming from some of the probability background. It is not like I've decided this thing and I'm collecting the sample. It is not like that. So it should have some probability. So it is basically coming by a chance of or the laws of probability. Okay, and if it is by some, if there is something like in my mind and it is according to my understanding of some of the subject, if I am collecting a sample or I am collecting the sample as per my convenience, or as or the or some investigator is selecting as per their convenience, then it may be a non-random sampling. Okay. So here in the first question, the investigator selects the respondents based on convenience. So if the respondents, so if someone wants to investigate about something, okay. So for example, there is a fruit juice which is in the market, and someone want to know that what person think about that fruit juice, but that person goes to the person which are present or which are residing in the neighborhood of him or her, and he goes there and asks for that whether they like the juice or not, and ask them and just do the things, and then just come to a conclusion that whether the person like or do not like, based upon that sample only. So that is based upon the convenience of the person. So he or she has not selected the sample based upon any sub background probability or something like that. So that basically the sample is not random, it is non-random. Okay, so it because it is based, the respondents are selected on the basis of the convenience of a person or a investigator, so it is non-random. Okay, now for the next question. A researcher wants to select a sample from a population of males and females. Okay, so there is a population of males and females. Now a researcher wants to select a sample from it. At each selection, a male is chosen with probability 1 by 3 and a female is chosen with probability 2 by 3. Then, then that sampling technique is a random sampling technique. Okay, so is it fine? Is it fine? So basically, it is a way that how the person is, so how the sample is taken from the population. So it totally depends upon how the sample is taken from the population. Now, what is basically in the background? What is in the background of selection of a sample from a population? So, if in my background, if I'm only seeing that, okay, I want to select, for example, a sample of males and females only, and I will just go to the person in the neighborhood or at my school or at my college, and I will just ask them a particular thing about whatever the data I want to collect, then that is basically based upon my convenience, because I know these person and I will ask only them. I'm not randomly selecting the person and asking for the data. Okay, so what do you mean by this probability 1 by 3, 2 by 3? So basically it has meaning, like for example, I have a population. Okay, I have a population omega, and here I have many persons. For example, let me write it to be x1, x2, xn. Fine. Now here, these are the persons, or I cannot write the x1, x2. For example, if I write male, female, okay. So it have male, female, female, male. So these are present in the population. Okay. Now what it can be? It is saying that male with probability 1 by 3 and female with probability 2 by 3. So for example, if I have a die, okay, or anything apart from a die, if I have whose which has three sides, for example, any structure which has three sides, and each side, so for example, for a coin, if I tell, so for a coin, there is equal chance that head will come or tail will come. Fine. So there is equal chance of probability that 1 by 2 chance of probability that head will come, 1 by 2 chance that tail will come. But the coin has two faces. For example, I have a structure which has three faces. Okay. Now three faces, and all the three faces have equal chance of coming. Or for example, it has three faces, and one face have 1 by 3 chance of coming, and other two faces have and okay, so wait. Well, let me explain it afterwards. Okay, so here what is there? So for example, let us consider a coin here. This is a coin, okay, which has head and tail. Okay, in general, the coin is unbiased, so we say that head has probability 1 by 2 and tail has probability 1 by 2. But for example, it is a biased coin. Okay, where the probability that head will come is 1 by 3 and probability that tail will come is 2 by 3. Okay, so you know about the probability distribution, which is called as the binomial distribution. So this is basically modeled by the binomial distribution, where the probability of success is 1 by 3 and probability of failure is 2 by 3, or 1 by 2, 1 by 2, whatever probability between 1 by 2, 0 and 1 can be assigned to these outcomes, these two outcomes. And here one is and the total probability is 1 basically. So in that way, I'm assigning the probability of head is 1 by 3 and probability of tail is 2 by 3. So this basically what this means, that out of if I consider this experiment 100 times, then 1 by third times the head will come, and the 2 by third time tail will come. Okay, in the total 100 times. So basically here I have this coin. Now I will toss a coin, and if the head comes, I will select the so basically I in the population I have male and female, and this is a male is chosen with probability 1 by 3. So if the head will come, I will choose a male. Okay, if the tail will come, I will choose a female. Okay, basically I'm tossing a coin at each point, and I'm choosing whether I'm choosing a male or a female. Okay, so then we'll say okay, the choice or the selection is based upon some, in background there is some probability concept is there running, through which I'm selecting this male and female thing. Okay, so this way, this is a one way of doing it. There may be other way also to do it. So is it clear now? Is it clear or some doubt? So what is the confusion? So basically, the thing is that in head and tail theory, in general, that no, non-random will not have any probability or something like that. So there is no probability concept. It is totally based upon a person's own thinking or convenience or something about a person which is not have a probability background is included. Then that will be a non-random sampling. So the non-random sampling do not have any like probability background or something like that. So for example, yeah, 1 by 3 and 2 by 3 are the probabilities. So basically, that basically means that out of 100 tosses, 1 by 3 times I'm getting 1 by 3. So what is 100 by 3? So it is um, so approximately 34 tosses, approximately 34 times I'm getting head, and what are the others? So 66. So and 66 times I'm getting tail, approximately, not exactly, but approximately. So basically, so what this means? So I'm tossing 100 times a coin. I'm tossing 100 times. Okay, then 34 times I'm getting a head, 66 times I'm getting a tail. So this probability basically roughly means those things. Okay, if that coin is unbiased, unbiased means that head and tail have equal probability. So then 50, approximately 50 times head will come, approximately 50 times tail will come. It can be like 49 and 51 also. So that will be approximately 1 by 2 only, like half of the time head is coming, half of the time tail is coming. But if there is some biased coin, okay, and out of 100 times this it is giving 34 times head, so there is some weight or something there in that coin towards the head, so that will land the head uh, uh, in the downward direction as compared to the tail. So the tail will come more times as compared to the head, so there is some bias in that coin. And in that scenario, this happens, and this kind of probability is assigned. Now each time when head come, I will choose a male, and each time when tail come, I will choose a female. So that basically choice or the selection of the sample is based upon some probabilistic approach. Yeah. Okay, so now the next question is, suppose a researcher wants a sample of 100 people with 60 males and 40 females. Okay, so basically the sample, the size of the sample is fixed, that I want a sample of size 100, and in which the number of males and number of females are also fixed. Okay, that's 60 males and 40 females. The researcher interviews people conveniently until these numbers are reached. Now, see, now how the researcher is collecting the sample. The researcher interviews people conveniently. So, based on his or her convenience, it is basically interviewing the people. Okay, so for example, the person is there in Rajasthan, for example, in Jaipur, he is sitting in the office, and because he or she is in the office, so he will ask the people according to his or her convenience that okay, fine, this is my staff. So in the staff, he will ask the other person, the males and the females there. And for example, there is staff of 200 people, then he will ask those persons, those people, and record the answers of those people about a particular subject. And he will again and again ask the person until the 60 males are completed and 40 females are completed. So it is basically, first of all, it is an on convenience. So that is obviously it is not a random sampling. Okay, so it is a non-random sampling first of all. Okay, and because there is some prefixed number, that's 60 males and 40 females. So that is so prefixed numbers. We are basically going to each and every. I don't know at how many person I need to go to get 60 males. So I want a sample of 100 people, but I will not go to 100 people. There may be a scenario that I may have to go to 200 people to get 60 males and 40 females. So that is a quota sampling. So that basically relies under the umbrella of non-random sampling. Okay, fine. So we'll move towards the next question. So here indicate whether the sample is a representative of a population or not. So this is another concept, that whether the sample which we are collecting, so whether it represents the population or not. So there are methods of random samples also, where we are collecting a sample based upon some particular technique, but that may not represent the population. So we should select a particular sampling technique that which for which the sample should represent the population. So however, that is another thing. Now here we are basically considering that we want to know that whether the particular samples which are given in this question, so they represent the population or not. Based upon our understanding, we will try to figure out that whether the sample will represent the population or not. Okay. So a researcher wants to study the average height of students in a school of 500 students. So a researcher wants to study that what is the average height of a student in a school where 500 students are there. She takes a sample of 20 students from the basketball team. So is this sample represent the population, or can we get the average height accurately if I consider these 20 students from the basketball team? Yeah, but so sample is collected. So she is collecting the sample. Now she can collect the sample from everywhere, no? So 500 students are there, but she is collecting the sample only from the basketball team. So sample is basically a subset of a population. It can be collected from anywhere you want to. So that will be a sample. Now that sample is good or not, that you have to make sure. So whether collecting a sample from the basketball team, is it good to select a sample from the basketball team? Or is it good to select the sample from each class of the school present? Or each class, and also we should take into account the thing that we should select equal number of girls and equal number of boys, so that we can have a good idea about the average height of the students. If we select the sample only from the basketball team, then there the heights of the students are generally high compared to the other students, because many students whose heights are more, they tend to go towards the basketball team and they generally have the more height. So if I collect the sample from the students who are having, all the students who are having more height, then the average height will be more as compared, but in the truth the average height of the student is not that high. Okay, so in this case it is not a representative. It's not about the proportion, it is about, so I want to calculate, I want to know the average height of a student. I do not want the proportion of the student, I want the average height of the student. So for average height of student, to calculate the average height, I should consider all type of students. The students who are 5 feet tall, who are 5'4" tall, who are 5'6", some are 5'2" also. But for example, I consider only the sample from the basketball team, 20 students from the basketball team. Now, based on that sample, so there are basketball team players whose heights are like 5'4", 5'6", 5'8", 6 foot. So these are the heights of the people in the basketball team. However, in the whole population, there are heights which are like 5 feet, 5'2", 4'8", also 4'10" also. So if I select the sample from all over the students, like if I take the sample from class third, I can take sample from class fifth, class eighth, class seventh, 10, some people from each classes, and then I constitute some 20 students, and then I just find out the average out. That will be more good as compared to only selecting the student from the basketball team, which already have more height as compared to the others. Are you getting? Yeah, so it is not a representative because generally basketball team has have people with more height. So the conclusion may be wrong if we consider this sample. Okay, now a school wants to know average weight of students. Okay, assume that each class has equal number of boys and girls. So if I consider class 8th, so class 8th has 50 students, and we are considering that it has half of the students are boys and half of the students are girls. This scenario I am considering beforehand. Okay, and the school wants to know the weight of the student, the average weight. So the sample include equal number of boys and girls from each class. So for example, here if I say, let me, so okay, so if this is a school, for example, I consider there are five classes: C1, C2, C3, C4, and C5. I'm assuming that each class, so if this class has 40 students, then 20 are girls, 20 are boys. If this has 30, then 15 are girls, 15 are boys. And if this class has 60 students, then 30 are girls, 30 are boys. So this is my pre-assumption. Now I want to collect a sample, so that so the sample is collected such that equal number of boys and girls are selected from each class. I want to know the average weight. First of all, the thing is that we have five classes. So maybe this class is 7th, 8th, 9th, 10th, 11th. Or from 8th, 9th, 10th, 11th, 12th. We have 8th through 12th classes. So in the 12th class, maybe the weight of the students are more. And in the lower classes, the weight of the students are less. So we should consider each and every class. So from each class, we should take some of the students. Other factor is that the boys generally have more weight as compared to the girls. So we should consider equal number of boys and equal number of girls, because there are equal proportion in every class. So every class we have a half number of girls and half boys. So we, for example, this class has in total 30 students. 15 are girls, 15 are boys. So we are selecting 5 girls from here and 5 boys from here. Again here from we are selecting 5 girls and 5 boys. From here we are selecting 5 boys, 5 girls. From here also 5 boys, 5 girls, 5 boys, 5 girls. So basically we are selecting equal number of boys and equal number of girls from each class, and we are selecting from each class. Okay, so and we are then calculating that what is the average weight of these students in order to tell that what is the average weight of the students in this school. Okay, so whether it represents the sample, so the sample will represent the population or not for this question. So basically our population has equal number of boys and equal number of girls. So basically if I consider equal number of boys and girls from each class and find out the average weight, then it have the quality, the sample has the quality that it will give you the very near average weight of the students, as compared to if I consider less number of boys or less number of girls, is the in whole the ratio of the boys and girls are equal. And also we are not leaving any class, we are taking the sample from each of the class. For example, if I leave the sample from class 12th, okay, class 12th students may have more weight. So if I leave the class 12, I do not take the sample from class 12th, I take the sample from the other classes. So that sample may not be good. If I leave, if I take more boys and less girls, then also the that may not represent the population. But if I take equal number of boys and equal number of girls, and if I take the samples from each class, then that sample will tend to give me a good results as compared to the others. So is it clear what I'm trying to say? Okay, so it is a representative. Fine, because the proportion of girls and boys are equal as that of population, and uh, uh, each class is considered. Okay, so it will represent the population. Okay, so next question is, so a hospital wants to know the average age of patients. So in a hospital, there are very type of patients. There can be children. Okay, there can be a person whose age is about 18. There can be a person whose age is above 25, who or below 30. So there are like every kind of a. So there will be children, there will be an adult, there will be old people also in that hospital. Okay. Now a hospital wants to know that what is basically the average age of patients. Okay, now a sample of 30 patient is taken from a pediatric ward. Now pediatric ward is the ward where only the children are treated. Okay, now if I take the sample from those of 30 patients from only the pediatric ward, so what the sample will represent? That the age of the patients is very low. So it will be a good representative of the population. So population will have patients of every age or almost every age. It will have children also, it will have adult also, it will have all old people also. Yeah. So if I take the sample from the pediatric ward, then it will not be a representative, because because pediatrics ward have children only. Fine. Now again, a school has 1000 students. A teacher selects 50 students from the list of the last year toppers to estimate the average marks of all students this year. Okay, so a teacher want to estimate the average marks of the students. Okay, for that it she selects 50 students from the list of last year toppers. So the last year the person who have topped, so she took 50 students from that and took out the average marks of those students in order to estimate the average marks of all students. So whether that sample of 50 students from the last year toppers list will be a good sample, whether it will be a representative or not. So because the list is taken from the last year topper, so if someone has topped last year, there is more chance that he or she will be having a good marks in the next year also. So it is not a representative. Okay, because yeah, so last year toppers we get 4 marks. Yeah, that's it. Okay. So yeah, so this way we can say, so so what are you trying to say? Anticipation is matter. So so what are you trying to say? I'm not getting. No, no. I'm not saying that. I'm saying that okay, there is a list of students. So this year some students got marks. Okay, and last year some those students got. So let me explain it here. So for example, this is 2025 year. This is 2026 year. So this year, for example, there are many students and some got 86 marks, 96 marks, 74 marks. For example, this is student one, student two, student three. Okay. Now this year, the students who got 96 marks, there is more chance that this year also he or she got some 95 or 94 marks. This is a like majorly this is true. It is not always true. He or she may get also less number of marks, but with many people, for example, out of 100 such peoples, there are 2 to 3 or 4 5 peoples are there who get less marks as compared to the previous one. Yeah, you can also talk about the grades also. So if someone is in here in maybe uh, seventh eighth class, and here if someone is ninth class, so in ninth the syllabus is like a little tough. But for that also, if someone got more marks last year, then there is more chance that he or she will do that much of hard work in the next year also to get at least 86 marks. Okay, but then the person who got 86 marks may get 76 marks also. So that is also the factor. So the toppers may get more marks as compared to that. And also if I reduce this factor also, if in the question if I write that okay, I'm talking about this year only. So if I get sample from the toppers list, toppers of this year only, then also this is not a good representative. Okay, but for if I am talking about the last year, then I am taking into account the thing that the toppers are generally performing better. Okay, if they are getting less marks, then then the persons who are getting, for example, less marks in the previous class are tend to get less marks due to their understanding of the subjects or those things. External factors I'm not taking into account in this sense, but yeah, there may be a factor, there may be a situation like that also, and there may be but we can say that it will not be a good representative. It will not be a good representative at all. If certain things like that also happen, then also it will not be a good representative, because we are basically we are just taking the toppers list and we are just collecting the data. So that will not be, that will create bias that in every situation. Okay. Okay, is it fine? Okay, so these were the questions for today. And we have almost covered all the topics which has been discussed in the week two lectures. Fine, I will be uploading this session on YouTube very soon, and the PowerPoint presentation. And here no ask script is available, so the PowerPoint presentation will be added to the Google Drive. And the deadline of your assignment is 4th February. If reason does not match, then is it acceptable? I don't think so. Is it acceptable? This collecting of the sample from the toppers list, is it? It is not acceptable actually, because we are basically considering a sample from a particular population. For example, if I divide the sample or if I divide the population into three groups, where one group is excellent students, one group is average student, one group is poor students, and I'm taking the sample only from the excellent students, then that will never be a good idea to get some inference about the population, because in the population each type of student is present, then we should take the sample from each and every category uh, of the population. More marks this year, you can say. So what is the problem? I'm not getting. So I'm saying that last year toppers may get more marks this year. So I'm saying here in the question, a teacher selects 50 students from the list of last year toppers to estimate the average marks of all the students this year. Okay, so the teacher is asking for, so teacher is taking the list from the last years, but he or she considering the marks for this year only. So because I'm talking about average marks of all students this year, so what are the students I should select? Okay, so if there are S1, S2, S50 students, or S total students are 1,000 students. Okay, now I want to select 50 students from it. So I'm selecting those 50 students who are present in previous droppers list. So I'm selecting S20, I'm selecting X21, and searchlight I'm selecting, for example, S70. I'm selecting these 50 students. Fine. Now, these 50 students, I'm selecting those students who were topper in last year. But this year, they got some marks. Now, I'm taking the average of those marks. I'm saying that. Are you getting what I'm saying? So I'm saying that the if I'm basically I'm taking I have this population of 1,000 students. Now I want to select 50 students from this population. Okay, now I'm selecting those 50 students which were there present in the top last year toppers list. Now I have selected these 50 students who were there present in the last year toppers list. So last year they got the highest marks. Okay, now this year they got some marks. What those marks are, they will be so okay. Then I'm selecting these students and ask these students at what marks they got this year. So in the last year they were in the topper list. So there is a chance that these students are getting more marks this year also. So whatever those marks are, I will take the average of those marks, and I'm taking that sample. So here I'm saying that it is not a representative, because last year toppers may get more marks this year also. And now if I'm getting, I'm taking more marks means more marks compared to other students. Now, if I'm only considering those students who are getting more marks as compared to the other students, then that sample may not be representative of the population, because population also consists all other students who are getting comparatively less marks. So then average marks, if I'm calculating average mark, yeah, because if I'm here considering only the toppers list, then here I'm getting the students who are having high marks. So for example, I'm having the students who are 96 marks, 98 marks, for example 90 marks. So the average will be around 90, but average marks of students in a class or is not 90. So there are many students who are getting 50 marks also. So that sample will not, so this sample is what this sample is representing, that okay, the students are getting more than 90 marks. Yeah, you should understand first of all the that what basically this a sample. So basically, for example, you are having a sample here today also. If I give you a sample, okay, there is a class, okay, of 50 students, and I taken a sample of 3 students, and I am showing you, okay, they got 90 marks, 96 marks, 98 marks. What you will infer from this information, that the students are very good at studying and they are getting marks of around 90 only. So it is not representing the population, because in the population there are students who are getting 50 marks also. But if I consider a sample where I'm having a sample which consists of 50 marks also, 60 marks also, 65 marks also, 90 marks also, 96 marks also, then that sample will represent the population, that okay, there are students who are getting low marks also, and there are some students who are getting high marks, and there are students who are getting average marks. Then the sample will represent the population accurately. Yeah, fine. So yeah, I was saying that the deadline of the assignment is 4th of Feb. So you just submit the assignments timely, and we will have the next session in for week 3 on 9th of Feb, from the same like 6 to 8 p.m. We'll having the session. If you have some other doubt also, you can ask. Okay, then we will be ending the session for today. Okay, so okay. Okay, fine. Let me end this session then. Okay, thank you for joining all. We will be meeting in the on 9th of Feb. Okay.